Hi, I'm Zina Ferris. I'm here to explain to you Chapter 2 Numeration System and Sets. The Chapter 2 has two sections, the numeration systems, and the second section, the sets. The numeration system represents numbers by symbols and by characters. We have the tally system, Egyptian, Mayan, Greek, Roman, Hindu, Arabic, and Hindu-Arabic system. This table shows the different systems from the Babylonian to the Hindu-Arabic system that we are using in our moment in the United States. The tally system, this system used the single strokes. So if you want to count from 1 till 10, we have the number 1 has 1 stroke, number 2 strokes, till the number 10 it's going to be 10 strokes. This system is simple, but it required many symbols. So if we want to count to 100, so the 100 is going to be 100 strokes. The Egyptian system consists of symbols. This table shows the symbol of the Egyptian system and also the description of it and the Hindu-Arabic equivalent. Right here we have an example of the Egyptian system. We have 2 scrolls, each scroll represented by the 100. We have 4 heel bone, and each heel bone represented by 10. And we have here the 5 of the vertical stuff, so each one represented by 1. So if you want to add it 2, it's going to be 200, the 4 is going to be 40, and the 5 is going to be only 5. So the 200 plus 40 plus 5 is going to be 245. We have the Mayan system. The Mayan system uses just only 3 symbols. We have the dot, it's 1, and the line is 5, and the symbol is 0. We have the Roman system. The Roman system was used in Europe. This table shows the whole symbols of the Roman system and also the equivalent in the Hindu-Arabic system. We have here an example of the Roman system. The Roman system, we have the M, D, C, L, X, and V, and I. The M represented by 1,000, the D 500, C 100, L 50, X 10, and the V 5, and the I 1. So if we want to add all of them together, we're gonna have 1666. We have another example. We have the V and has a line on the top. So the V, it's the equivalent of it's 5, and if the V had the line on the top, so we're gonna multiply it by 1,000, so it's gonna be 5,000. We have here the second example. We have C, X, and I, and 3 lines on the top. So the C it's 100, the X is 10, and the I is 1. So we're gonna multiply them by 1,000 power 3 because we have 3 lines. So the total is gonna be 111 times 1,000 power 3. We are here to talk to the second section, the set. The set is a collection of objects. Any object in the set is an element. For example, we have the set if we have the English alphabet. So if we want to import it as the set, we have to start with the set from A, B till the Z. The order in the set doesn't make any difference. So we can, like we have in here, K, E, and Y. So we can write it like Y, E, and K. The set represented by the N set, it's a numeral number, so from 1, 2, 3, 4 until the infinity of number. There's 2 methods that we can describe the set. The first method, listing method, so we're gonna list the set. So we have a set we're gonna list it. So we have 1, 2, 3, 4, and 5. We have the set builder notation. The set builder notation is the A set. It's equal to the set of X is the nominal number where X is less than 6. So the X is going to be less than 6 because we have from 1 till 5. The set builder, if we have this equation in the set, we have 3x plus 1, where x equal 2 and 3 and 4. We have to solve first this equation. We have in here the table that we solve this equation. We have x equal 2, 3, and 4. We have to put the 2, we have to put 3x plus 1, so it's going to be 3 times 2 plus 1 equal 7. So the set is going to be A equals 7, 10, and 13, like we solve it in this equation. We have equal sets. The equal sets is when the two sets have the same element. But if those sets are not equal, so it doesn't have the same element in two sets. We have the one-to-one correspondence. The one-to-one correspondence is going to be on two types, like with the arrow connection and also with the tree diagram. The arrow connection, when we have the same number of elements in both sets. We have in here A, the set is Sam, Mary, and Tom, and the B, 1, 2, and 3. So we have the same number of elements. We have 1, 2, and 3, and here 1, 2, and 3. We're gonna draw the diagram that represent the arrow from Sam to 1 and Mary to 2 and Tom to 3. So those are the same number of elements in two diagrams. And you can write it also at this symbol, the equivalent, each one by the second. The tree diagram, we're going to represent this table to a tree diagram. So we have Thomas, Dick, and Mary, and also Mary and Dick. So we're going to represent this table and put it in the tree diagram. We have the subset and the proper subset. The subset is every element of A is an element of B. So we can write it like this symbol is the subset. If we are talking about the proper subset, so it's every element of A is an element of B, but we have one or more element of B is an A. So we can write it also in this symbol. The intersection between the two sets and also the union between the two sets. The intersection between A and B, it's all elements common in both A and B. For example, we have A, 1, 2, 3, 4, and 5, and we have B, 3, 4, 5, 6, and 7. If we want to do the intersection between A and B, so it's going to be 3, 4, and 5, because the 3, 4, and 5 it's in A and also in B. And the union it's the set of all elements in A or B. So we have, for example, A equal 1, 2, 3, 4, and 5, and B equal 3, 4, 5, 6, and 7. So the union between those two sets is going to be 1, 2, 3, 4, 5, 6, and 7. We're not going to repeat those three elements because we have them on the two sets. The difference between the sets. We have the difference between A and B. The difference is the elements that are not in B. So we have A, B, C, D, and E, and F, and set B, A, B, and C. So if we want to do the difference between A and B, so it's going to be D, E, and F. And if we want to do like B minus A, so the difference between B and A, so it's gonna be empty. So that's the whole chapter that I explained it to you. Thank you.